Part 2, some more examples. There's all kinds of different answers you get from these quadratic formulas. So I want to give you as many possible answers as possible. This does not equal 0. Does not equal 0. That means I'm going to have to move something. I'm going to take this 12x and move it over here to make it negative 12x. Take this negative 18, move it over here to become positive 18, and then it'll equal 0. So that means that A is positive 2. B, once I move it, is negative 12. And C, once I move it, is positive 18. I just did that in my head. If you can do it in your head, go for it. If you need to write it, write it. So x is equal to, put numbers in place. Negative b, b is already negative, so it becomes a positive 12. Plus or minus the square root of b squared. Squaring negative 12 gives me positive 144. Minus 4 times a times c all over 2 times a, 2 times 2 is 4. So x is equal to 12 plus or minus the square root of, work out inside that radical, 144. Negative times positive is negative. 4 times 2 is 8. 8 times 18 is 144. Ooh. All over 4. Space up here. X is equal to 12 plus or minus the square root of 0 over 4. My discriminant is 0. Do you remember what a discriminant of 0 gives me? It gives me only one solution, one root, one x-intercept. That's because the square root of 0 is 0. Well, 12 plus 0 and 12 minus 0 gives me 12 both times. So I don't have to split it this time because I'm not going to get two separate numerators. My answer is just 12 divided by 4. Because 12 plus 0 is 12, 12 minus 0 is 12. That means that x is equal to just one answer, one solution, and that's 3. That means the vertex of that parabola will be right on the x-axis. Let's see, it's an upward-facing parabola because a is positive. So it'll be over here at 3. The parabola will look something like that. It would intersect the y-axis at positive 18. That's that number, positive 18. All right, a couple more. Once again, does not equal 0. So I'm going to move some stuff mentally to make it equal 0 and make sure I fill in the right signs here. A is 5. B is already over here at negative 8. And C's got to move over to become negative 6. So put our numbers in place. X is equal to negative B becomes positive 8 plus or minus the square root of b squared, 64, minus 4 times a times c. And that whole thing is all over 2 times a. 2 times 5 is 10. Let's calculate inside of that radical. 8 plus or minus the square root of 64. Negative, positive, negative gives me a plus. 4 times 5 is 20, times 6, 120. All over 10. Slide up here for some space. X is equal to 8. Finish with the computation inside the radical. Plus or minus square root of 184. Uh-oh. Now I have a not very nice number over 10. 184 is not a perfect square. Here's what that means. Because it's not a perfect square, my square root is going to be an irrational, non-terminating, non-repeating decimal. What that means is that this polynomial, 5x squared minus 8x minus 6, was a prime polynomial. But it's still going to have x-intercepts. Those x-intercepts are just going to be at irrational points on that x-axis. They're not going to be exact. We're going to estimate them. In this case, we're going to estimate to, say, the 10th place. So let's split this up. Oh, erase that. Split this up into two separate equations. One with the plus, 8 plus. I'm not going to do anything with this square root of 184 yet. Never round in the middle of the problem. Always round at the very, very end. So I'm going to do my calculation, but doing this calculation now is where the order of operations becomes an issue. If you put 8 plus square root of 184 divided by 10 all in one shot in the calculator, it's going to divide first and then add. We can't do that. We have to do this numerator first. Remember, this fraction bar is a grouping symbol. So we need to get an answer to this, take that answer, and then divide by 10. And when you get the answer to this, you're going to get an irrational decimal. Do not round it. Just leave it in your calculating tool, whatever you're using, as it is. So I'm going to grab my calculator. I'm going to press 8 plus the square root of 184. That gives me 21.564, blah, 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 blah. I'm going to keep that in the calculator and then divide by 10. That gives me 2.1564, blah, 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 irrational. I'm going to round this one to the 10th place. So I'm going to cut it off here. This 5 rounds this one up. So it's 2.2. If it's at hundredths place, I would take the 5 and round it up to become 2.16. So just make sure you read the directions if it says tenths or hundredths. And on this side, I'm going to do 8 minus that irrational square root of 184 divided by 10. Same process. 8 minus square root of 184, enter. Gives me a negative 5.564, blah, blah, blah. I'm going to leave that decimal in there, and I'm going to divide it by 10. I'm not going to round until the end. So I get negative 0.5564, and then more. I'm going to round this to the 10th place again, so I'm going to cut it off here. This 5 gets rounded up because of that 5 to become negative 0.6. You really should put your answer the proper way too, because these are not exacts. These are estimates. If one's an estimate, they're both going to be estimates. So it's negative 0.6 approximately, and approximately positive 2.2. You would not have been able to factor this polynomial to get these answers. So to get the solutions, the quadratic formula is not the only way, but it's the best way, in my opinion, to get these two answers. You wouldn't have been able to factor and use a zero product property. It would not have worked out. All right, one more, last but not least. This one's going to be your favorite. Again, doesn't equal 0. I'm going to have to move that over. So let's see. A is positive 2. B is already negative 5. And C, when I move it over, is going to become positive 7. So let's put our numbers in place. X is equal to negative B gives me positive 5 plus or minus square root of B squared gives me a always positive, 25 minus 4 times A times C all over 2 times A, 4. Do some computations in that radical. 5 plus or minus square root of 25. Negative, positive, positive gives me a minus. 4 times 2 times 7 is 56 all over 4. So x is equal to 5 plus or minus. Well, now I've got an issue. Because 25 minus 56 is not a positive number. 25 minus 56 is negative 31 all over 4. But the discriminant's negative inside that radical. And if you remember, a negative discriminant gave me no solutions. And that makes sense algebraically now because you think you know a square root of a negative number isn't real. There are no square roots of negative numbers. You can't do this. So because you can't do the square root of a negative number, I can't get a solution. So this equation will have no solutions. That means that this parabola will not hit the x-axis. Because the a value is positive, it's going to be facing upward, and it's going to come down and not reach the x-axis and go back up. It's going to come down right about, let's see, right about here. It looks something like that. So it'll be an upward-facing parabola with a vertex above the x-axis. Maybe something like that. And then this would be positive 7 here. That's the y-intercept, the c value. So no solution for this one because inside the radical, the discriminant value became a negative number when I worked it out. All right, here's your quadratic formula with a bunch of different types of solutions. Have fun.